And I am pleased with the quality of the submissions, right? Just, if you didn't make a great grade, no problem. Revise, resubmit, you will make a great grade. I'm happy to give out like 90% A's in the class, and I'll fight tooth and nail, if I was ever challenged on it, and I never have been. Because, if y'all know the work and you're ready to go on to other classes, then that's what I want. All right, so what is today's date, and what lecture are we on? I don't remember. We're on lecture.
Are we on N?
Yeah, that sounds right. Okay, we're on N.
Today's 25th.
Hope everybody had a good break.
Sure.
All right, so big point. If you have an input statement in pseudocode or an input block on a flowchart, you will expand that to 3 lines of code if it's a number in your Python. However, those 3 lines of code can be condensed into 1 line. Still, you're going to have to expand it if you don't do that combination correctly, right? So you don't just turn input rate into rate equals input. Instead, do this. Print what is the rate, question mark, and then get the rate equals input, and then rate equals float rate. Or you can condense them into 1 statement in this particular language, not every language. Rate equals float, parentheses, input, parentheses, what is the rate, question mark. I'm kind of fond of that one because it leaves the cursor on the same line as the print statement rather than below it. But, it's a little bit longer, more prone to syntax errors. A lot of time people leave out the last parentheses. Yeah, I've done it too. So it's all good, if either way you want to do it. What you can't do is just leave it like that. And if you're going the other way, if you're going from code to a flowchart, you don't necessarily have to do the print statement and then the input. You could just put the input statement. I'm not gonna mind either way, right? It's totally cool to display the message that you're asking for and then have an input block underneath it. They both need to be in tilted rectangles, or you can just put input, right? Because a flowchart is designed to be implemented in any language, and so we don't put a lot of specifics in it, a lot of syntax specific stuff, or specify too closely what it's going to do. We getting volume today? Yeah, all righty. All right, we're going to be done with chapter 3 today, which is good. We're a little bit behind the other class, but that's because we lost the first Monday of the semester, and then we had another day when I wasn't here. I think we had a snow day as well, so that's why your exam is later than theirs. They took theirs before the break. Speaking of exams, let's check when the exam's going to be. I think it's going to be next week. April 3. Yeah. So we'll do a review for the exam this Thursday. The exam shouldn't be too killer. There's going to be a flow chart, a bunch of multiple choice type questions, a few fill in the blanks. It is so based on the C-Engage stuff. While I'm at it, I'm going to give you the answer to one of the questions that like 80% of the other class missed when they took the exam. It said something like this: how do you test a program? And one, with all legitimate
legitimate input. 2, with one set of legitimate input. And 3, and I have a beef with how this is worded, but it was taken almost word for word out of the C-engage. And then lastly, with a reasonable set of legitimate input. Now, I don't remember it had the word reasonable in it, but the vast majority of people chose all legitimate input. Sometimes that's possible, right? But not very often, right? If it asks for your pay rate, are you going to enter every possible pay rate from 1 cent up to $1 trillion or whatever? You know, there's an infinity of possible numbers that you could type into. So you would not choose all legitimate input. With one set of legitimate input, well, that's how programmers do it, right? I write the program, I run it, woohoo, it worked, right? Now, you got to try it with multiple sets, with reasonable sets of legitimate input. You have to run it, a couple of times. Make sure it works if the user enters 0. Make sure it works if they enter good data. Make sure that if you have an if statement, that you test both ways. Like you put under 40 hours for the pay, and then you put more than 40 hours. And realistically, you should test your boundary conditions. What are your boundary conditions? If you have an if statement, if x greater than 40, check to see exactly what happens at 40, and then one less at 40, and then one more at 40, right? Because that's the boundary, right? If x 40, x is greater than 40, test what happens if it's greater than 40, test what happens if it's less than 40, test to see if it's exactly equal to 40, right? You got to test all branches of your program in order to have a good job of testing them. Now, our programs have not been so complex that it's too hard to do that. Okay, here's my beef with this, with all legitimate input. The user could be giving illegitimate input, right? They could be typing in, data that's not correctly formatted. It asks for a name and they type in a number, or they hit enter, instead of typing in a name. Or it asks for a number and they type in, the dollar sign in it, and you're not supposed to allow the dollar sign, right? That's the kind of stuff that can crash the program. So, there should be another choice, right? A reasonable set of legitimate input and also some illegitimate input. But anyways, that's the correct answer. And I don't remember that it's worded exactly like that, but it's certainly not all, because you're not going to test it infinitely. And it's not just one set of input. So, definite test question. Now you know what the answer is. It's not the one that says all, and it's not the one that says one set. So I'm just going to put some big no's here. No. No. And then yes. All right. That's like the single question that most people got wrong. And it was from the C-engage, but on the other hand, it was from the first C-engage. And if you've done all three of them, then it's back, further back in time. Do review those. Just step through every question, right? Kind of serves as your flashcards. And you'll have a flowchart to draw. It's not going to be a complex one. I don't even think that there's any if statements in it, so it's pretty clean. Yeah, there is an if statement in it, but no modules, right? If statements are easy. They just have 2 branches and they hook back up in the middle. And thankfully everybody got that. Everybody drew them hooking back up in the middle without a dead end. I could be wrong. Maybe somebody didn't do that. There were some missing flow lines, but unless it was a flow line where an if branch didn't come back together, I wouldn't have counted off a lot for that, because that's just like carelessness. And if you're in a hurry on an exam, 2 blocks here aren't connected. I'm not going to go, oops, you failed that one, 20% off your exam score. Right. But everything should be connected by flow lines. So everyone's going to get this one right, correct? All right. So combining structures. We've been talking about structures. What are structures? Structures are the logical units of programming. That sounds like a complicated way of saying it. But one unit of programming, one structure is your sequential. One statement after the other. One block after the other on a flow chart. Then there are 2 others. And we already talked about this, but on the other hand, it was a week ago, so we're going to refresh our memory. 1, sequential. Statements one after the other. And then 2, decision, which for us is if statements. Let me make sure they don't call it selection. Some textbooks call it selection or use the term, both terms. Okay, they did call it selection. Go back. I think in my quiz question, I put one of them in parentheses. So, textbook definition is selection. That's the textbook definition of the second kind. I'm going to also put decision in parentheses because that makes it, or I'll just put that over here, right, like that, in the description of it. And then lastly, repeating code, which is loops. So, loop structure, which is repeating code. Which incidentally are while loops and for loops. And you can use these in any combination, right? You could have a loop that's, you have sequential statements, and then you have a loop diamond. And then inside that loop, maybe you have an if statement. And on one branch of that if statement, you have more sequential statements. And on the other side of the if statement, you have another loop, right? Those are the fundamental blocks. I would argue in a way that function module calls are a fourth programming structure, right? Because it's a way of repeating code, right? Multiple modules call, the same, multiple chunks of code call the same module. So modules are a way of implementing both sequential code and loop structure. But the book doesn't say that, so I'm not going to go with it. I might just put that as a comment. I would argue that modules are a fourth structure. Now I've lost what page number we were on. Yeah, there we go. So any structure can be nested within another. What's nested mean? Nested means, just like when I was, you're not going to have an example of nested. Yeah, right, thanks. Okay. Well, then I'll draw one real quickly, or at least I'll bring up one that I've drawn in the past. Here's what a nested structure looks like in Python or in pseudocode, right? You have some statements, blah, blah, blah. A is equal to 1, whatever. You have a whole bunch of whatever. And then you have an if. And then you have another if, right? Another indentation level. And then maybe you have something indented under that, right? And I'm going to put an end if comment here and an end if comment here just to make things easy to see. Okay, right like that? This is an example of nested structures. The while loop is nested inside of an if, which is nested inside of another if. Just like eggs are nested in birds' nests. Just like Russian dolls have the baby doll inside the mother, inside the whatever. So, like this. I'll go back to that page real quick. And here's one. All right. So we have an if statement. Well, print how many cookies? Input cookies. And then if the cookie is equal to 0, this looks like bad logic. Yeah, definitely bad logic. I must have been on cough syrup that day. If cookies, this should probably see greater than 0, right? Because if cookies is equal to 0, then this while loop would not work. So realistically, I mean, I'm sorry. I just can't leave an error like that for future generations to find. Isn't it weird that, like, in the future, like in the 2500s or something like that, if, you know, civilization crumbles and then another civilization comes back up and, you know, they're doing archaeology, they're going to find all these photographs and printed books and stuff like that up to about the time that computers became popular. And then all the photographs will be on computers, you know, and most of the texts will be on computers, and so, you know. Anyways. So, this is nested inside the if, right? We have a while loop nested inside the if. So, every time you start a new column, and then if you start another column, right? You can nest sequential statements inside of a while. You can nest whiles inside of an if, and so on. You can just mix and match them any way you need to. One more I wanted to show y'all. Where'd it go? I have a flow chart that illustrates this. I mean, a PowerPoint that illustrates this. But basically, this is just which of these is a single selection decision?
One more time.
A single outcome selection as opposed to a dual outcome. One of them is a single outcome decision. You might say this one, but it's wrong because that's a loop. It's not a selection, it's not a decision. Even though it has a single outcome, right? Well, it doesn't. If we repeat that. This is a single outcome. This is a dual outcome. It just has two branches, the yes and the no branch. Single outcome means it's something or nothing. Dual outcome means it's something or something else. And then we have a loop, and then we have a nested loop. Just the difference between drawing an if statement and a loop is that an if statement hooks back up underneath, and a loop has a line going back to or above the while block. This is how the book shows it, going above it. This is how I like to do it, with the line going back to. Doesn't matter. Logically, they mean the same thing. So, there's a such thing as a priming read. And we've talked about that before. But when you're asking for data and you're going to allow them to exit, logically, there's different ways of handling that. But the textbooks all show this. The scripting textbook actually shows the alternate way of doing it. So a priming read looks like this. Get the first input. And then if the input is not equal to the sentinel value, what's the sentinel value? It's the one that causes input to end, right? Enter score, or negative 99 to stop. If the input does not, or actually let's make that a while. While the input does not match the sentinel value, do something with it, and then get the input, get the next input. Why is it called a sentinel? Excuse me. Why is it called a priming reed? Just like when you're trying to get water out of a pump, right? Pumping is when you're pressing the handle and water's coming out to fill the bucket, right? But before the water starts coming out, you got to prime the pump. You got to press it and press it until some water starts trickling out, right? We have to get some input before we can go in the loop. Now, that's not my favorite way of implementing loops, but the book doesn't talk about my favorite way of so I think I'm going to just go ahead and roll with this for now. And we could actually code something like that. And it's always annoying to code input, have input statements in one of our, our nodes, because then each time we run it, we have to enter input or whatever. But something like this, right? X equals float, parentheses, input, parentheses, quote, enter X, or -999 to quit, parentheses, or end quote, and then 2 close parentheses. This still has all 3 components of an if statement. It's got a prompt. Prompting is the print statement. It's got the input and it's got the conversion. You would skip the conversion if you were letting them type in a word rather than a number. All right, and then while X not equal to -999 colon, do something with it, right? Print parentheses, quote, X squared equals, end quote, comma. And by the way, a lot of people did this on one of my exams. I don't remember if it was in scripting or in this one. But that's not a valid symbol. You see that little hat, the caret, whatever that's supposed to be called. Can't do that. In our language, what is the exponent operator? Yep. Star, star, times, times. And then we got to get the input again. We just need another, we can just copy and paste that as long as it's indented. And we're good to go. That's the quickest way to handle it, so I'm just going to copy it. Just make sure it's indented correctly. And then we'll print, I guess we could put an end while comment if we so chose. And then we're going to print done underneath it. Right, this is the priming read. The first input is the priming read. Guess I better add that as a comment. So I'm going above the first input and I'm saying the first input is the priming read. And I'm going to add a comment to that -999, which says -999 is a sentinel value. -999 is the sentinel value. What is a sentinel value? It's something that's supposed to be a non-valid piece of piece of data that tells it when to stop. Now, in this particular case, we might really want to use -999, right, as a valid value. And so that's not actually a perfect implementation. But like if it's a test score, if your professor will give you a -999 on an exam, then I would drop the class and find a better professor. So you wouldn't want to make that a possible value. You'd want to let them out. I mean, that could be a good sentinel value. We should probably also have something that validates the data. And what do I mean by that? Check to make sure that the score is not below 0. Because unless your professor's a jerk, your score should not be less than 0. Or greater than the maximum possible score, right? If 100 is the max, we could code that as the max. I'm not going to go ahead and show that loop for now. But validating input to make sure it's within the correct range is a good thing to do. All right, and let's just test it to make sure that we've got it going on. 1, 1 squared is 1, 2, 2 squared is 4, 3. Okay. Probably all we need to say about priming reads until I'm ready to show you a different way of implementing it.
Real quick question.
Yes, sir.
What is the input to have it do a carriage return? Like when we run it?
Oh, if you want it to go to the next line,
Yes, sir.
2 ways to handle that. One is you could just take this out, and I'm going to show both ways. Y'all don't have to make this change, but if you want to, you can just do the print above it, right? And then it'll go to the next line.
Oh, okay.
Or put a slash in. Slash in means character turn, go to the new line. And that's the, which slash is that? That's backslash, the one above the enter key, not the one underneath the question mark.
That's not going to show up in the...
Right, let's go ahead and run it and make sure that I didn't lie. Ooh, invalid syntax. Okay, what did I do wrong? Anybody spot the syntax error? Right, I have 2 open parentheses and no closing parentheses. And take a note, it highlighted this and you'll go crazy. There's nothing wrong with that line. I'm absolutely, well, if you can't figure out what's wrong with the line, look on the line above it. All right, so now that I've done that, like I said, y'all didn't need to make those changes, but if you did, go ahead and make them and make sure. All right, so now, oh, well, what do you know? Did I do something wrong? Yeah, I typed it in wrong. Okay, so now it's working probably the way you asked. And those backslash n's are good for formatting your output a little bit better. Like if you just have a straight sequence of stuff, it can be hard to read. Just like if you separate paragraphs with a blank line, it can be easier to read, right? And so if we wanted to, we could put a backslash before the done statement and another one after the done statement, backslash n, right? And then, right. Just makes it a little bit easier to read. You'll see backslash n in just about any programming language. It boils down to what's known as an ASCII character. And it just means new line. Go to the next line. There are other backslashes as well. There's tabs. Like this. Print parentheses quote. 1 end quote, end parentheses. Print parentheses quote, backslash t, 2, end quote, end parentheses. And we're not going to do this for too long, but print parentheses quote, backslash t, 3, end quote, end parentheses. What's it going to do? It's just like hitting the tab key. Right? 1 wasn't tabbed over, 2 was tabbed over once. Apparently it puts 8 characters per tab, whereas a lot of time we see 4 characters per tab in other environments, and then 3, like that. So let's go ahead and mention that in our notes. Backslash n means new line. Backslash t means tab. There are others, but that's enough. All right, we've typed for 30 minutes. Anybody have syntax errors that you would like my eyes to stick to your screen? It's kind of gross. I'd be glad to do it. Everybody doing okay? Oh, by the way, let me come to you and help you configure your Mac in something that won't bring up Xcode every time you type in a Python program. If you're using a Mac and every time you double click on the Py file, well, I'll just tell everybody this, but the way you fix it is to configure how you want those files to be opened. The way you fix that differs based on which operating system But if you double click on a file and it just runs it rather than editing it, right? If I went into here and I double clicked on my lecture in because I downloaded it and it just runs it rather than edits it, you can always launch idle and go edit it that way. You can open the file that way, but you can also right click on it and do open with. And it could be that edit with idle is just listed right there. But if you wanted to do it by default, when you double click on it, you do open with, and you choose which program. Right now, it's set to open with Python, meaning it's just going to run it. But I want it to open in idle, so I'm going to right click on my py file, do open with, and where it says other programs, I'm going to click on that. Well, I'm going to click browse, and then I have to go find the idle file. And that's a little bit more of a pain than it ought to be. I'll leave that as an exercise for the viewer. I'll show you how you could do it, but I would have to quit this app and then come back to it. Phooey. All right. How am I going to find the path for idle? I'm just going to launch idle again. Come up here and do File, Save As, and it's going to show me the path, right? It's in all that. I could highlight all this. It's different for the Mac users. It's actually easier. Then click copy that, and then I can come back over here and remember what I was doing. I was trying to set the default program. So I right-clicked on the lecture file. I did open with. I did browse, and then I find my Python subdirectories, and I'm not going to go through this too slowly. And then you find lib, and you find idle lib, and then there's idle.bat. That's the one that you want to open your files every time you double click it. And then every time I double click it, it's actually going to open it inside the editor. For the Mac users, you come up, you click the file, and there's something like an edit menu. And then under the edit menu, there's a properties menu, and you can select which application you want to open it from the properties menu. But I'll show that to y'all individually. Anybody with a Mac can raise your hand at the end of class, and I'll show y'all. All right, I'm sorry that it's not easier. The other thing you can do is if you've installed idle on it, you ought to be able to right-click on the file and choose. Oh, I'm not even seeing it now. It was there before. Y'all saw it bigger than life. It said edit with idle. Maybe that option has gone away now that open with has been chosen as the default program. All right. Hope that helps. If you want your PC here to do that, again, raise your hand at the end of class and I'll come help you with it. So watch for unstructured loops that do not follow this order. Ask the question, that's the priming read. Take an action based on the answer, and then return to ask the question again. There's a priming read done as a flowchart. Input the number. Is it not the EOF, the end of file? Right, then do a calculation, output the answer, come back up here again. This is wrong. Why? Because it needs a second input. Otherwise, it's just an infinite loop. It's going to print an answer over and over and over. It doesn't have the second input. You'll have a priming input, and then you'll have one inside the loop as well. You may think, if you're drawing a flowchart, that you can just draw the line coming up above the input statement, and that would fix it. Well, but that's not the way while loops work, right? You can't just jump up, an arbitrary number of lines in the code. Instead, that second input statement would need to actually be it need to be indented in the code. Now it's correct, right? We have a priming input, and then we have a second input here. This is the first one that lets them go into the loop, and this is the second one that keeps getting repeated until they write some invalid piece of data. Until they enter the signal value. So the reasons for structure.
Well, Python doesn't let you write unstructured programs. So that's the big reason. But you use structures in order to maintain the clarity of the program. And I think I showed y'all like some code for the Apollo moon landing stuff. It was all written in assembler. They didn't have the words for and while and stuff like that. They just had jump statements and things like that. So assembler lets you write unstructured code. However, the NASA engineers were very careful to go ahead and write structured code anyways, simulating the structures that we have with those base machine languages. So, makes the code clear to follow. You don't want spaghetti code. We can't write spaghetti code in this language, but you don't want it. In a professionalism, other programs are expecting you to do structured code. Most languages require it. Efficiency, most languages support it. Maintenance, it's easier to read the code. And then it's modular. You can break that code easily into modules. What do I mean by that? Do you remember the nested code I had? You could take that inner loop and turn it into an entirely new module, right? Because if that inner loop was 100 lines long, maybe it needs to be broken out into a module or two. And then that loop could just call the modules to do the heavy lifting. Structured programming is sometimes called go-to-less, meaning without go-to statements. Because back when languages did support go-to as a keyword or jump, then it led to spaghetti code. I've done that lecture, right? Spaghetti code bad. All right. Here's a nested, right? Here's a sequential, and then underneath that sequential, there's a decision, a single outcome decision. And then here's a loop nested inside another loop. And a process, calculation, nested inside the inner loop. This is called the inner loop, just like if you have a little doll inside of a bigger one, and this is the outer loop, the outermost loop. And you can nest things more than 2 levels, right? You can keep hitting that tab key and makes 20 loops nested within each other. However, that logic would be pretty difficult to follow. We are about at the end of the chapter. So, summary, spaghetti code. Does not follow the rules of structured logic. Here's your 3 basic structures, sequence, selection, and loop, which are combined by stacking and nesting. We know what priming input is now. We know what structured code does. Makes your code easy to read and maintain and make modular. Flowcharts can be made structured by untangling the logic, because you can draw flowcharts that cannot be implemented. That's why it's a good idea to write pseudocode as well. And then the logical steps can be rewritten to conform to the 3 structures and only the 3 structures: sequence, selection, and loop. All right, gang, I paused the recording for a moment. I forgot to unpause it, so this is what we were covering. This is how to validate input to make sure that they don't type in invalid numbers, like letters when it asks for numbers. It uses something called try and accept. And I'm not going to ever ask this on an exam, and I'm not going to ask you to do it in a program. So you can just ignore this part, or you can look at it, try it out, see if you can try to understand it. So pause the recording. Look at this. What's going on is the try marks the code that could crash, specifically this statement. And if it does crash, it's going to jump down to this accept statement and run it. This is the kind of thing you couldn't flowchart. It's more sophisticated than flowchart support. All right, onward and upward. I'm going to pause it again, make sure nobody's getting syntax errors who's trying to follow. So we want to make our program loop until we're ready to stop. What we're going to do is we're going to wrap the whole thing in a great big loop that kind of looks like this. We're going to scroll all the way up to the top, and we're going to start our loop. Go all the way to the first line of code that's not green.
And I'm going to have a word that says repeat equals, quote, y, end quote. That's going to be our variable that we loop on, otherwise known as the loop control variable. And again, until I demand this from a program, you don't have to do it. But if you feel like coding it this way, then I'll be impressed. So then we have to while on that, right? While repeat, repeat equals, quote, capital Y, end quote, colon. Now you're going to highlight everything from that point on and tab it over one. And when I say everything, I mean down to the very last line of the program. So my favorite way of highlighting a bunch of stuff is to move my cursor to the beginning of that line, hold the shift key, and start hitting the down cursor. Like that. And then hitting the tab. Or coming up to format and choosing indent. There.
One more time, what'd you do?
Let me do it again. I put my cursor at the first line that I want indented.
Yes.
I held the shift key and the down cursor to highlight everything. Now you can just use your mouse, but this is a lot cleaner, a lot faster in my opinion. Then you hit the tab key.
Hold shift and hit tab.
Nope. Hold shift and down cursor.
Okay.
Keep pressing down cursor. It highlights more and more until you get to the bottom. And I did something wrong. I typed in a 3 rather than a tab. Good thing that there's undo commands. Once more it's feeling. Highlight it all except for the while loop and hit tab. But we need some way of getting out of it or else it's just going to repeat forever. So we're going to ask the user if they want to repeat. So repeat equals input parentheses quote. Do you want to repeat or run again? Question mark, and then I'm going to tell them what they can type. Y/N space end quote in parentheses, right? And then I'm just to let them know that everything's done. Okay, program done. End quote in parentheses. That's how you make a program loop. Put a while statement up at the top. You ask them if they want to repeat down at the bottom. And it'll keep repeating as long as they keep typing Y, right? They can calculate several paychecks or whatever they're trying to do. Play the game again. Sometimes this won't really work. Like our turtle programs, hide our window behind the turtle, and they won't know that they're supposed to go back and type in anything, right? So you won't be putting that on something like that. But otherwise, if it's all text input, it's a good thing to do. Let me make sure it works before I brag too much. All right, enter X of -999. Okay, anyways, blah, 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 -999, age of 1. And then down here, although we can't see it, it now says, do you wish to repeat? Why, yes, I do. And it would keep repeating as long as I typed in a Y there. And I finally hit no. Okay, program done. So our entire program is now nested inside a while loop. Alrighty. Now we're not going to have as much time for homework. If we need to talk about homework, we can go down to my office after. I'm not sure I mentioned the homework assignment with the recording on. This is going to be the homework assignment. Turn this flowchart into a program. It uses a priming read, just like our notes did. Pretty easy after that. All right, let's make a Dropbox and we'll be done. I'll wander around and make sure everybody's got it. Yeah? Yeah, sure. Okay. Let me make the Dropbox first for those who are done.